Okay, Assalamualaikum and good day. So in this video, we will move on to the new chapter, applications of differentiation. Okay, the first subtopic will be on related rates of change, or known as rates of change. Okay, the idea here is we want to find the rate of change of one quantity in terms of another quantity whose rates of change are known. For example, we want to find the rate of change in the area where we have known that the rate of change for the radius. Okay, the steps for solving related rates problem. Okay, the first one would be you can draw the diagram if possible, but it is not compulsory. Okay, and label the quantities. This one should be one of the first thing that you need to do actually. Label the quantities or extract the information. Okay. Extract the information and then find the equation that relates the quantity whose rates of change is to be found to the quantities whose rates of change are known. That means define whatever you want to find, define them, and then use the chain rules or implicit to differentiate both sides. Okay, this one is up to you which one is suitable for that question, and then solve for the derivative that will give the unknown rates of change. Okay, don't be too rigid. The most important thing is to understand what you need to find, extract the information, and then solve the problem. Okay, let us see the first example. Okay, the example here that we have is air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cm3 per second. So how fast is the radius of the balloon increasing when the diameter is 50 cm? Okay, extract the information first. Okay, as you can see here, air is being pumped into a spherical balloon. So that means being pumped in positive. Okay, because the balloon will get bigger and bigger. Okay, so it involves volume. When it is volume, that means the power here should be centimeter cube. Okay, volume. Okay, 100 positive. Okay, and then plus there is another hint here increases, that's why it's plus. So we want to actually search for the dr dt because how fast is the radius actually. So that means we are trying to determine here dr over dt when the diameter is 50 cm, which means when d is equal to 50 cm. Okay, this is actually the gap where we try to solve the problem. This is the info that we have. Okay. Okay. So, first we need to derive this equation, the chain rule equation. Okay. We have we want to find the r dt and we know the value for dv dt. So thus here would be dr over dv. Okay. The simplest way for you to determine that chain rule would be dr over dt means dr over something times something over dt. So we have the info for dv dt, the value for dv dt. So here would be dv dt by right. Okay. Therefore, we need to find dr over dv. Why? Because after we cancel out dv here, we will have dr over dt back. Okay. So right now, the volume for a sphere is V equal to 4 over 3 pi r cube. Okay. Therefore, dV dr is equal to 4 pi r squared. Okay. Remember, bring the power forward and subtract the power of r. Okay. dV dr is 4 pi r squared, where dr over dV would be 1 over 4 pi r squared. That means we just switch it. Okay. And then, dr dt would be equal to dr over dv times dv dt. That's why here we substitute dr over dv times dv dt. Okay. Simplify, we have 25 over pi r squared. Okay. And then we want to find the value for dr dt. So we need to substitute the value for r. but we were given the value of diameter. Okay, diameter is 50 centimeter, and hence R is equal to 25 centimeter because D is equal to R. Okay, and lastly, you just need to substitute the value of R equal to 25 centimeter in the dr dt. Okay, calculate, you will have this value 0.0127 centimeter per second. Okay, please give your answer at the very least in 4 decimal places. Okay, and also don't forget the unit. Okay, the unit is centimeter over second per second because dr dt radius is actually in the unit is centimeter. Okay, thank you.